Do you ever hear a still voice telling you what to do? You have to print a sub 6-minute Benchy. Convincing you to do something you know is completely unnecessary. It's definitely necessary. Did you hear that? No. Well, unfortunately, I do.
In part 2, we managed to print a sub 10 minutes Benchy. And unfortunately, that completely hooked me into wanting to go even faster. But there's two things holding us back: the Hotend and Y-axis.
So today, we're fixing both.
In part 2, we managed to get a flow rate of around 31 cubic millimeters per second, which simply isn't enough.
Now yes, technically I could print faster by using thinner lines and layers, but that won't give me faster Benchies. According to the speed Benchy rules, I'm limited to a maximum of 0.5 and 0.25 millimeters, and thicker lines means less lines, and less lines means, well, less time, and that equals to faster Benchies.
So, how do we fix this?
Well, the solution to all engineering problems is more power.
Now, I could technically solve the problem by swapping out the heater with a more powerful one and adding a melt zone extender.
This is way too boring.
Or I can use this. This is the Triangle-lab CHC XL, an absolute ridiculous water-cooled hotend with a massive 128 watts of pure heating power. And according to Triangle-lab, this thing can push up to 130 cubic millimeters of plastic every second.
Now I think this is going to be enough, and if not, well, we might need a flamethrower.
Now for the Y-axis. In part 2, we established that the motion system could sustain the following speeds and accelerations. But the moment I tried pushing beyond that, the Y-axis started to lose some steps, and increasing the current didn't help. So to fix this, I have two options: reduce the weight or add more power. To reduce weight, I would either need to remove the magnetic base or the silicone's mains heater.
And both of them are bonded to the carbon plate, which means there's a very good chance of destroying the plate while trying to remove either one of them.
And honestly, a bed that reaches 100 degrees under 2 minutes,
I'm definitely not giving that up.
So instead, let's go with more power. Now these are the LDO Kraken motors, with a rated current of 3 amps and nearly double the amount of torque as the previous motors.
Now this should give us enough torque to violently sling around a 2 kilogram build plate. Now that we have a semi-decent but questionable solution, let's figure out how we're gonna attach everything.
Now the Triangle-lab kit does come with a mounting adapter, so I could just mount it directly to the existing tool head.
That's definitely not going to work. It's way too long. It looks like a 1970 Cadillac sticking out of the tool head. I think I'm gonna need a new bracket. And what can that be? How on earth did they know I'll be needing this?
It looks like PCBWay knows me better than I know myself. Whether you need a custom PCB, something CNC'd, 3D printed, or laser cut,
they've got pretty much every manufacturing method you could think of.
And as you can see, no matter what the process, the quality is always excellent.
And their turnaround times are ridiculously fast.
If you want to check out their quality for yourself, you can use my link in the description below to get $5 off of your next order. Thank you PCBWay for making all of this possible. Now that we know we can actually mount this beast of a hotend, we also have to make sure that our cooling can keep up with it. So I designed a completely new duct and optimized it just to make sure we get the most out of the turbofan without completely suffocating it. And more importantly, to make sure we're actually cooling the parts and not the hot end.
Now with all of the parts finally done, I now have to print them. But before I can do that, I first need to add the enclosure.
I'll be using acrylic for all of the panels, which I'll be cutting to size using my DIY CO2 laser cutter, which features an extremely advanced cooling system, powered entirely by ice cubes and zip ties. So if you want to see me rebuild my laser cutter as well, comment laser down below and I might just show you how I did it. Now for the enclosure, all of the inner panels that's also a part of the electronics cabinet is mounted directly to the frame using these custom brackets. All of the other panels are attached using these filament latches, while the rear panel is attached with slightly modified Voron mounts. I then added some LED lighting to the inside and added a filament pass-through bracket up top that also acts as a clamp for the top panels. And for the doors, I just used modified Voron hinges and handles so that they are bolted to the panels instead of using double-sided tape. And with that, the enclosure is done and we can finally start to print.
I'll be coming up hot for a minute. Everybody know the drop when I'm in it. Drop the top when I'm in it. Everybody know the drop when I'm in it. I'll be coming up. Everybody know the drop when I'm in it. Drop the top when I'm in it. Everybody drop when I'm in it. Yeah, I'm so. Everybody know I'm on. You know when they click through. Try to send it supposed to be a
Now that looks mean. Now originally I did route the tubes over the carriage, but honestly I think it looks better like this.
And believe it or not, this tool lid is actually lighter than the previous one.
I definitely didn't expect that. As for everything else, that's pretty much exactly the same, except for this dedicated power line for the new heater that will be directly connected to a solid state relay. Now, while I was busy replacing the stepper motors, I also added a water block to the X-axis motor. And now the only thing left to do is to update the printer config files, redo input shaping, and then we can finally see if all of this actually made a difference, or did I just waste my time and money.
At this point, I started to feel optimistic, which was my first mistake.
That's definitely not right.
And after a few minutes of playing detective, I found out that my linear block had too much play.
It's definitely the block.
Turns out you really do get what you pay for when you buy your linear rails from Temu. Shocking, I know. So I did the only reasonable thing and replaced it with something slightly above average.
Now that's 1,000 times better.
And after redoing input shaping again, I was actually quite surprised by the difference the new rail made.
Now the time has finally come to see how good this Hotend actually is.
To keep things fair, I'm going to use the exact same speed test as in part 2.
Now honestly, I don't know what to use here. Triangle-lab claimed they got 120, but that's with a 1.2mm nozzle. So let's make it So the first defect is around here, and it looks like it's just over 18 millimeters. So let's go with that.
And that is equal to the flow rate of 43 cubic millimeters per second.
We need just a little bit more.
So I increased the nozzle temperature and ran the test again, and managed to get a slightly higher flow rate of 46.5. And just to make sure it's not the filament holding the Hotend back, I ran the test for a third time using some high-speed PLA and got a slightly higher maximum flow rate of 48.5. That would be able to sustain a maximum print speed of 388 millimeters per second.
Now with that done, let's see if we can make this thing complain.
To do that, I'll be using Andrew Ellis's speed test and start with the limits we found in part 2 and keep increasing the accelerations until the printer goes. Now I expected the Kraken motors to put up a fight, but not this much.
Now previously we were able to get 500 millimeters per second at 25k acceleration. We are currently stable at 500 millimeters per second and 420k acceleration without even losing a single microstep. These Kraken motors are absolutely insane.
Now most sensible people would stop here, but I decided to go even faster, only to be shown by the motors once again.
Now we're currently sitting at 700 millimeters per second at 60k acceleration, without losing any steps. Now who said you can't have best of both worlds?
Luckily for me, we finally found the limit.
Okay.
Now here is the maximum stable speeds and accelerations that I ended up with. Now that we know the limits, let's put it to test.
It's Benchy time.
Now before we completely throw quality out of the window, I first want to print a Benchy I can properly compare to the Benchy from part 2. I'm going to print all of the Benchies using the exact same quality and strength settings and only adjusting the speed settings. I started with the profile that gave me the sub 12 minute Benchy in part 2.
Sub 12.
And then adjusted it to take advantage of what the new Hotend can actually handle. And after a bit of tuning, this was the result.
Tried getting a quality Benchy and ended up getting my fastest Benchy yet. And personally, I think this one looks better than the previous one.
But I'll let you decide. But quality isn't why we're here. Let's see if we can get that sub 6 minute Benchy. Now to even stand a chance of getting that, I'm going to be extremely optimistic with these settings. I'm setting them well beyond what the Hotend is realistically able to deliver. And to compensate, I'm switching to the high speed PLA and increasing the nozzle's temperature as well.
So close. 6 minutes and 8 seconds. And it actually looks quite decent. Now to try and shave off another 8 seconds.
No matter what I tried, those last 8 seconds just refused to disappear. And trust me, I didn't only try 1 or 2 times. I tried more times than I care to admit. And the only ones that actually printed faster lost steps.
Now did I get my sub 6 minute Benchy? Well, no. But 6 minutes and 8 seconds, that's close enough. But the goal of this printer was never just speed, but speed, quality and convenience. And in all of those, it really did exceed my expectations. But I still have that speed itch that needs some scratching. But for that, I think I'm going to use this. So if you want to see me make questionable decisions on yet another 3D printer, make sure you subscribe. Now for what's left of this printer, well, I still need to finish the electronics cabinet that I'll definitely try and convert into a piece of art, and then add some nice to have features like the chamber heater.
Now I already went ahead and added a camera and a touchscreen that I'm planning to mount right here.
Now to some of you who complained that I barely reused any of the original printer's components, well, I figured out a way to fix that.
You can now build a version of this printer while still reusing the original heater, wide gantry plates, steppers and most of the electronics. The only things you'll really need is some additional aluminum extrusions, all of the printed parts, some linear rails, something to run clipper on, and if you decide to add the EBB36 board, you can even run all-wheel drive on the Y-axis.
But I'll share all of that information once the project is finished. But for now, all of the files for the printer in its current state is available for download. Just keep in mind that it's not finished and it's still a work in progress. Thank you to each and everyone for watching this video. I really appreciate all of the support and interest into this project. Now if you don't want to miss the next part, make sure you subscribe. And I'll see you in the next one.